So what do you do when your oven isn't baking? Well, you pop the cover off and give a look, see what you can do. So what's going on is the broil works, but the bake doesn't. So this is best case scenario. I can put my meter across there, see what the impedance, what the resistance is across that one, across that element compared to the bottom. And we got, kind of three possibilities. One, it's not getting the signal telling it to turn on. It sounds like it is. I hear the little relay clicking. Second, it's getting the signal, but the element's toast. That's my guess. Or third, you can have a good signal, you can have a good element, but bad power. I don't think it's that. I think it's this one right here. Let's check. Again, don't do what Johnny Don't does here. The educational purposes only, but we're pulling about 14 ohms. Let's check the bottom. And here we are across the bottom, and we're an open circuit. Now, I'm no certified service tech, but I would say that doesn't look right. So let's get you close up here, and yeah, that ain't right. So what happened here? What I did is I cut the other side open, but you got your electrode that comes in here. There we go. We got a ceramic insulator that goes in, right? Because you don't want this thing to be live, because otherwise the whole oven essentially will electrocute you. Goes into this coil. Now inside of here, there's some magnesium oxide. I took the liberty of cutting it open. 1 second here. Took out the old hacksaw for your viewing pleasure. And so you can see that white powder on the inside. There we go. So that's magnesium oxide. There's the electrode. So what you need is, you're putting your current across the electrode, the wire in the center. That's why this thing heats up. But you can't have it conductive. So you got magnesium oxide in the center to be an insulator, but it's also nicely thermally conductive. So it's both best of both worlds. So that way the heat will transfer from the electrode into the element to make your oven heat up. And so what happened over here was obviously just a complete breakdown of it. Most likely you can have a slight little defect. And with the magnesium oxide, it doesn't like water, any moisture. So if you get something in here, it can break down, and all of a sudden, catastrophe strikes, and this thing essentially starts welding itself to death. And there goes your element. See here, what happened is that magnesium oxide went up in smoke. I'll put on the screen there what the oven looked like on the inside. All this powder that was in there, that's the insulation in there, that magnesium oxide layer. So the craziest thing about this whole thing, the replacement one, the OEM, they want $240 for the same piece of crap that lasted 2, maybe 3 years, versus I get the aftermarket one, which is built exactly the same factory, even comes pre-bent, so I got to put that back into place. Just total trash, but the same part. There's no difference with this thing. $50, and this will last probably the same 3 years. Okay, so everything's back in there, and honestly, if you need instructions on how to put the thing back in that you just took out, you probably shouldn't be doing this. In a display of extreme confidence, I'm going to set the clock before I even turn this on and test it. Okay. There we go. I hear a little humming. Okay, so I did get a little ahead of myself. It didn't turn on, but that's okay. I gotta talk quiet because everyone's in bed. So anyways, this is handy when they include the circuitry so you can go through this. But I'm having a look here, seeing what's going on. And I suspect it is this sucker right here on the bake element. We got a relay and it's not closing. So what I'm going to do here, I got my meter all set up. So I'm going to check this relay. We'll go P7 to P3 through the broil element. That works. So even audibly, I should hear it click, and a moment later, hear a click. And what should happen is this will click. So this will be open circuit. I go across these two. I'll hear a click. It's going to connect up. I should check momentarily. See, I'm going to put the meter to check resistance. I should momentarily see the resistance across the coil, like 14, 15 ohms. This will close, and then the resistance between these two should go to 0. And I have a guess. If I do the same test here, across here, it'll go click. I'll see the resistance across the element, the bake element. Same thing, 14, 15, 16 ohms, and it's going to stay there because that sucker isn't working and you're not going to hear a second click. Okay, so we're across the two terminals. I'm checking out the, that is the broil element, that's the bake. So let's go through. Turn that on. We'll just go low. Perfect, so 2 clicks. Let's turn this off. Okay, so we heard the first click. We saw the resistance of the coil, and then another click went to 0. So let's move to the other side. Where are we here? Trying to do this through the phone. Don't short nothing. There we go. All right, let's put it to bake. Let's try this puppy out. Okay. Oh, see death. 13 ohms and only 1 click. Okay, just to be thorough, I'll check the other side of the circuit. So I'm just essentially going across the element to the other side of that relay. So we should just be measuring that, turn on the broil, and now that should go to 0. Perfect. Do a little switcheroo here. Careful. Okay. Same thing. That's the impedance of the bake element. Let's try that out. And that's where she stays. All right. So that's the deal. That's the problem. So the whole element went. And I don't know, maybe that blew the frickin' relay somehow too, because that was a catastrophic failure. I don't know, that's kind of crazy. So I gotta go find me a little picture of this bad boy and pop out the board and swap out that relay. So I stopped in at the local electronics shop here in Vancouver, Lee's Electronics on Fraser. This place has saved me so much money on my appliances. They don't have the exact same one as I need. This will do the trick though. It's got 2 extra pins that I don't need. So I just chop those off and pop it in the board. Got a spare just in case. While I'm at it, let's get some wick so I can do a nice job, a flux pen, some extra solder. Tried my luck with the scratch and win, and that was a bust. So the old relay is out, the new one is in. I think this thing is, what, a whopping $4.50. It's a slightly different part, but it works no problem. So, yeah, let's put this back together. Here's a tip, solder suckers. Pop that down, hit the button, sucks the solder right out when you're taking out your joints. Well, here's the moment of truth. Let's see. Oh, you gotta set the clock for it? Okay. There. Uh-huh. I heard 2 clicks. Come on. I'm feeling heat. Oh, it's warming up. I can feel the heat. Oh, that's a win. So I'm almost curious if this was the problem overall. There's that little melty bit right there at the top of the relay. I'm wondering if this thing went and this is what caused the element to go bonkers and just kind of blow up there. But anyways, like I said, this oven chose the wrong person to break down on. When it's me versus appliance, typically I'm the guy that wins. Anyways, I hope you didn't mind my diversion from my regular fountain pen videos. I got more coming up, but this is kind of actually more important than fountain pens. Saving yourself, whatever, $1,500, $2,000 on an appliance when it's perfectly good. And you can get her done for $4.50.